This video is a continuation of the 2-4 notes that we started in class. Let's jump to example C. It says f of x is equal to x squared times the square root of 1 minus x squared. We need to differentiate this. In order to differentiate this, we need to start by getting rid of that square root. So we're going to rewrite it as f of x is equal to x squared times the quantity 1 minus x squared to the 1/2 power. So you should now notice that we need to use the product rule because x squared is a function in and of itself, and 1 minus x squared to the 1/2 power is a function. Hopefully you also recognize that there is stuff within our second function. So in order to differentiate this problem, we need to use the product rule and the chain rule. The product rule states that in order to differentiate a function that deals with the product, f prime of x is equal to the first function, which is x squared, times the derivative of the second function. Take that 1/2 power, move it out front, so 1/2 times 1 minus x squared, and then that 1/2 power minus 1 gives us to the negative 1/2 power. But that differentiation is not yet done because it's the chain rule. So we took the derivative using our product rule first, and now, or using our power rule, using the power rule first, then I need to tack along the derivative of the stuff, which is going to be negative 2x. So that took care of first times the derivative of the second, plus, product rule states, we need the second times the derivative of the first. Before we go any farther, we need to clean this up. So we're going to clean up around our plus sign. I can put together the x squared, the 1/2, and the negative 2x to give me f prime of x is equal to negative x cubed times the quantity 1 minus x squared to the negative 1/2. Oops. Plus, we're just going to take this 2x and move it out front. Looks a little nicer that way. So 2x times 1 minus x squared to the 1/2. Now we definitely don't like this negative exponent that we have here, but we also have a common factor, that being 1 minus x squared. So let's pull that out. When we do that, we always pull out the lowest power of what's in common. So the lowest power between negative 1/2 and positive 1/2 is going to be the negative 1/2 power. So then we're going to be left with negative x cubed plus 2x times. Now the problem is, if I were just to multiply the 1 minus x squared to the negative 1/2 into the 2x, it's not going to give me my original power of 1/2. So that means I need to have 2x times the quantity 1 minus x squared to the first power in here. When I do go through and multiply, if I were to distribute this in, pen's not working. There we go. To distribute this in, we would be where we originally left off in the previous step with negative x cubed times 1 minus x squared to the negative 1/2 plus 2x times the quantity. When I multiply two powers with the same base, I add their exponents. So that negative 1/2 power plus 1 gives us our original positive 1/2 power. So we're going to get rid of all the extra notes. Okay, so now we're going to continue to clean up. Go back to my red pen. f prime of x is equal to 1 minus x squared to the negative 1/2. Even though this is in parentheses over here, I can distribute the 2x because it's only to the first power. So we have the quantity of negative x cubed plus 2x minus 2x cubed. Cleaning up by combining our like terms here, we have 1 minus x squared to the negative 1/2 power times negative 3x cubed plus 2x. Probably thinking there's still a GCF. We still have a common factor inside, that being an x, so let's pull that out. F prime of x is equal to 1 minus x squared to the negative 1/2 times x times quantity negative 3x squared plus 2. Only problem we have now is this negative exponent. So finally, our answer is f prime of x is equal to x times negative 3x squared plus 2 over 1 minus x squared to the 1/2 power. Okay, we pulled out all of our common factors, we made all of our exponents positive, and now we are done. Mission accomplished. Let's try D. First we need to get rid of all these notes. Okay. Problem D is asking us to differentiate f prime of x, f of x, is equal to, getting ahead of myself, x over the cube root of x squared plus 4. We definitely don't like the radical down there in the denominator, so we need to take care of that. Let's just make it a power, an exponent, and then we can use our quotient rule. You also have the option of bringing that whole thing upstairs into the numerator and making it a negative exponent, but we want to work with our quotient rule instead. So let's rewrite our function. F of x is equal to x over the quantity x squared plus 4 to the 1/3 power. Clearly we need the quotient rule because we have two functions, one in the numerator, one in the denominator. Hopefully you also recognized that we need the chain rule when we differentiate our denominator because there's stuff there. So let's go ahead and start differentiating. F prime of x is equal to low d high, so low is x squared plus 4 to the 1/3 power times d high, the derivative of the numerator, which is 1, less high d low, so high is just x. D low is the derivative of the denominator. In order to calculate that derivative, we take our power, bring it out front, 1/3 times x squared plus 4. Subtract 1 from that power, that exponent, so now we have the negative 2/3 power. But we're not done yet. We need to tack along with our chain rule the derivative of the stuff, which is going to be 2x. So we have low d high less high d low. It's all done. All over denominator squared we go. So if we're going to square that denominator, it means taking x squared plus 4, which is currently being raised to the 1/3 power, and now we're squaring that. When you take a power to a power, you multiply your exponents. So let's multiply those exponents and kind of clean up what's happening in the numerator. So we have f prime of x is equal to x squared plus 4 to the 1/3 power minus, you can multiply that together with that and that, so we have minus 2/3 x squared times x squared plus 4 to the negative 2/3 power all over x squared plus 4 to the 2/3. We still have a bit of a mess in our numerator, but you should identify that again we have a common factor of x squared plus 4. So we're going to pull that out, and again we're going to pull out the smaller of the two powers, which is going to be the negative 2/3 power. So if we do that, f prime of x is equal to x squared plus 4 to the negative 2/3 power. I then am left with, in the first half, in order to get from a negative 2/3 power to a positive 1/3 power, I need to add 1 to it, so it's going to be x squared plus 4 to the first power minus that 2/3 x squared all over the x squared plus 4 to the 2/3 power. Okay, we're going to take this negative exponent, we're going to bring it down, clean up in the numerator some more. F prime of x is equal to x squared minus 2/3 x squared is 1/3 x squared plus 4 in our numerator. Oops, don't really need parentheses. Over, when we bring that down, it becomes x squared plus 4 to the 2/3 times x squared plus 4 to the 2/3, which was already there. When we multiply two powers with the same base, we're going to add their exponents. So we're almost done. We're just going to move over to the right side here. Change to red ink. So we have f prime of x is equal to 1/3 x squared plus 4 in the numerator over x squared plus 4 to the 4/3 power. One thing left. Can't have a fraction up there. So in order to make 1/3 a 1, I can simply just multiply that by 3. So I'm going to multiply the whole entire fraction by 3 over 3, which is technically a form of 1. When I do that, I need to make sure I distribute it into my numerator. So my answer, f prime of x, is equal to x squared plus 12 all over 3 times the quantity x squared plus 4 to the 4/3 power. And we are done for now.